Okay, for this one, our first step was to factor each of these coefficients. So I made a factor tree for 198 and for 88. 198 is 2 times 3 times 3 times 11. 88 is 2 times 2 times 2 times 11. We're like 2 goes into 88 44 times, 2 goes into 44 22 times, 2 goes into 22 11 times, so 88 is 2 times 2 times 2 times 11. In any case, we have the factorizations of 198 and 88, and now we want to put these two the product of these two radicals under one radical, because the square root of a times the square root of b is the same as the square root of a times b. So here I did all that. I put now 198 times 88, we can combine all the factors. So 2 times 2 is 2 times 2 times 2 times 2 is 2 to the 4th power. There's 1, 2, 3, 4 2's. See, I'll check them out. 1, 2, 3, 4 2's, 2 to the 4th. Then there's 2 3's. 3 times 3 is 3 squared. And there's 2 11's. 11 times 11 is 11 squared. And then in the x department, you've got 13 x's plus 3 x's. That makes 16 x's. And 9 y's plus 6 y's add up to 15 y's. So, there we have it so far. Now we're going to divide all those exponents by this invisible 2 that sits outside of every square root radical. So here we go. 2 divides into 4 twice with no remainder, so no 2's will remain under the radical. 2 divides into 2 once with no remainder, so no 3's remain under the radical. 2 divides into 2 once with no remainder, so no 11's remain under the radical. 2 divides into 16 8 times with no remainder, so no x's remain under the radical. But 2 divides into 15 7 times with a remainder of 1, so 1y remains under the radical. So what this all equals is, let's see, 4 times 3 is 12, and 12 times 11 is 132. And we have x to the 8th, y to the 7th times the square root of y on the end. So this is how our radical simplified this time.